Job scheduling on the Apollo guidance computer. It's the 1960s. The space race is in its final stage, with both the USA and the Soviet Union trying to be the first to land a man on the moon. For the Americans, it became quickly apparent that the rocket alone won't do the trick without the onboard means to navigate the spacecraft through space. That's when NASA and MIT developed the Apollo guidance computer, or AGC for short, which, compared to state-of-the-art equipment of its era, was tiny. The AGC runs its own broadly scheduled, multi-programmed, real-time operating system called Executive. This OS, among other things, manages the computer's processes for guidance, navigation, flight control and other computational tasks. Executive offers different routines for things like restarts and error recovery, managing I/O, the user interface and processes. Job scheduling in general is an integral part of a multi-programmed operating system. This means that the system switches rapidly between processes to give the user the illusion of running multiple programs at once. This is necessary, as at some point, processes have to wait, for example for an I/O operation to finish. In the meantime, other processes should be able to utilize the CPU. This raises questions about when to switch from one job to another and how to choose the next process. Jobs that are ready to run are usually in a queue, in case of the AGC, a priority queue. Job scheduling on the AGC itself works a little differently from what we are used to today. These are some, but not all of the subroutines the OS offers regarding process management. The information about a process is stored in a data structure called core set, with all core sets stored in a table. This table stores its entries in no particular order, except for the first one called core set 0, which always stores the data of the currently active process. So, to switch from one job to another, core set 0 has to be swapped with the core set of whatever process should be run next. After a call to any of the executive subroutines, the system scans the priorities of all processes currently in the core set table. If a process has a higher priority than the currently active one, the such-called new job register is set. But even if such a job is found, the current process remains active. It is the task of the running process to check the value of the new job register at least every 20 milliseconds. If it contains a value greater than 0, the process has to call the change job subroutine, which performs the actual context switch. You may have noticed that for this scheduling scheme to work, every process has to regularly and reliably check the new job register. In the case of a program crash, the such-called night watchman comes into place. This part of the hardware monitors the access to said register. If more than 614 milliseconds have passed since the last check, the system automatically performs a restart to resolve the situation. The AGC, with its operating system and all its other software components, is an outstanding feat of engineering, which, apart from a few bugs, performed brilliantly on all its Apollo missions. If you'd like to learn more about this topic, I've linked my resources in the description below. Thanks for your attention.